to Embedded Systems Practical 7. Our today's topic is how to control media player and PowerPoint presenter on your laptop or desktop computer using your TV or DVD infrared remote control and Android phone via Bluetooth. This is the device I have built. I call it Bluetooth IR remote PC media remote control with external load switching terminal. So this is the device. Here I have my laptop computer, and then on the other side I also have my desktop computer. Now if you look around, normally our laptop and desktop computers, normally they don't come with stuff like this. So most times I want to play media on my computer. I will be asking myself, how can I be able to use a TV remote control or a DVD remote control or any other remote control like this ones? How can I use this to be able to control media on my computer just as the way we use it on our televisions or other appliances? So here I have come up with an idea. I built this so that I can add infrared remote control function to my laptop computer. What you have here, this is a USB cable. Here I'm going to connect it. So that's a USB cable. Then this other end goes to my to your computer. It could be a desktop computer or a laptop computer. So you see, so with this I can be able to control. Here we have infrared sensor. So with this now I can be able to control media player and Microsoft PowerPoint presenter on my computer. Now the way this works, what I have here is a microprocessor here. Look at it here. This is ESP32. I have it in here. You can see the USB port here. So this goes to the computer. So here I have written an Arduino program here running on the microcontroller. Then on the computer I also have developed a software using processing programming IDE, which is based on C and Java. So with this now, instead of coming down here pressing the space bar for play and pause, that's if I'm using a VLC media player on my computer. If I press this, I display and pause. So what I did was to write program for these buttons that I've decided to use them on the computer. So what I did was that if you look at my arrow keys here on the laptop, you can see these arrow keys on your computer keyboard. So what I did the same thing. I mapped this to my arrow keys: up, down, left, right. Then this menu key, I map it to enter key on your laptop. Then one of these green one, I use it as play. Then this previous, and this is next. You understand? So that's what I did here. So with this now, I can be able to control either by PowerPoint presentation using an infrared remote control. And not just that, this system here has inbuilt Bluetooth, so which means I have also developed an Android app. You see, an an Android app which is also going to connect with this. And it doesn't depend whether your desktop computer is having inbuilt Bluetooth or not. My Android phone connects directly to this. So I've also developed an Android app also that will be installed on the Android phone using an app inventor. Where on my Android phone I can also control media on my computer, as well as I can also use the infrared remote control to control media. So let's look at how the system works. So before I show you some of the components, now let's take a look at. Now this is infrared remote control we are all familiar with in our houses. I believe you have one of these in your house. So these remote controls you see, if you press any of the key, any of the buttons here, it transmits digital data, the data in digital format and in an infrared medium which our eyes can't see. So on the other side of our gadget, there is an infrared sensor that have to receive the signals as they go in. Then based on the computer program, the microcontroller will now decode. Now before you write code for any remote control, you must have to decode the remote control, the buttons. Each of these buttons here, they have values, they have commands. So you need to know the value of that command. So after decoding them, you write it down and then you reuse it in your program. For example, now if I want to use this button to control a light, I need to decode this button depending on whatever programming language that you are using to do that. So here in this my own case here, I use Arduino C programming language. So I have to decode the button, the value this button is transmitting. I need to get it down so that in developing the program, I will tell my microcontroller, if you receive a certain value, this is what you're going to do. So that's just the system here. And then how did I transfer this into computer? Then there is a software on the computer side that is going to be listening. Now what I did here was that my ESP32 microprocessor is going to receive the commands, then send it to the computer. The software on the computer is going to interpret the command to the operating system as if they are from computer keyboard. So what I did, I mapped the keys on my keyboard, the ones I want to use to controlling my media. I map them to the, for example, now if you are using a VLC media player, if you press the space bar, it's play and pause. So I map it to this green button here. Then if I press N, it's next. I map it to this blue button here. If I press P on the keyboard, that is previous, I map it to this yellow button. Then if you still press your space bar or S, that is stop, I map it to this red button. You understand? That was what I did. So before we come back, let's take a look at the block diagram. Before developing anything, you need to start from the block diagram. So let's take a look at our diagrams here. So in our previous practical, which is embedded system practical 6, we developed something for controlling power. In this case now, we are dealing with communication. So you see how to control media player. For instance, I use VLC. We commonly use VLC media player. It's a very good player that supports almost all the formats. And also PowerPoint presenter, like your Microsoft PowerPoint on your laptop or desktop computer using TV remote. Like if you look at this remote control, all this remote control there. If you have, now there are some gadgets that are no longer in use or they no longer function in your house, but you still have the remote controls lying around. You can use them instead of throwing them away. Or if you don't have any of these, you can easily get them in the market. They are easily available. So I can like use them to control things, stuff around instead of TV. Now in this case, now we're using it for something different. So this is the block diagram that I have here. You have the infrared remote sensor. The sensor is what receives, when you press any button, you see this infrared LED. It will emit some radiation. So this sensor is going to pick it up. So here, let me show you the sensor I'm talking about. This is it. So this is the infrared remote sensor. It is here. Then we have Bluetooth module. This microcontroller here has Bluetooth and Wi-Fi. This is ESP32 SoC system on chip. So it has inbuilt Bluetooth. So I don't need to connect external Bluetooth. It has inbuilt Bluetooth. So we have our microcontroller, which is this here. Then we also have some LED indicators. We have used the LEDs. You can see a lot of LEDs there. And then now in this design, what I added something. Let's say your computer is connected to a projector and you guys are watching movie in the evening, and a lighting system, you want to as well turn off a lighting point, also from the remote control and also from your Android phone. So I decided to add something. You see, this is a switch. There's a relay in here. It's a switch. This is a 12-volt power supply. We should control the relay here. So that's why we're having this relay driver switch here to control external load, which is going to be powered with 12 volts. So here we need power supply. Now since this is taking 5 volts from the computer via this USB cable, we don't need to power the device system externally. This 12-volt power supply is for driving the relay. So if you don't need it, you don't need it. So since we are connecting this to a computer via our micro USB cable, so it is going to supply power to board. Now take note, this microcontroller here uses powered, works with 3.3 volt, although there is an onboard 5 volt regulator on it. 3.3 volt regulator. You understand? So straight to the computer. So here we have our infrared remote control. Then we also have our Android, although I'm using the phone here, it's an Android phone. So that's how the block diagram is. When signals come from the remote control, the microcontroller decodes them and then send them to the computer. The software on the computer interprets the commands and send it to the operating system. So whichever application that is running in the background, like the media player that is highlighted, is going to control the arrow keys, play, pause, and the stop keys. They are going to control your media player and also your PowerPoint presenter. So let's take a look at the circuit diagram. Before you design anything, you need to create the circuit diagram. So just as I've said here, this is SoC, call this SoC, system on chip. It's a combination of microcontroller and microprocessor. So this is an SoC, ESP32. So it has inbuilt Bluetooth and Wi-Fi. So you see, so then we have our infrared remote sensor. This is our infrared remote sensor here. You understand? Then we're going to have some LEDs, indicator LEDs. This one is if you are connecting the 12 volts source for driving the 12 volt relay. That's where you need this. Otherwise, if you just connecting this into a computer, you don't need it. Just like the way you are seeing your USB cable, USB serial. What we have on this board is this USB to serial system that we have here. So it's USB, so it will appear on the computer as a serial port. So there's a USB serial cable to your computer. You understand? So the 5 volt from the computer goes to this board. The 3.3 volt regulator will regulate it to 3.3 volt and then powers the microcontroller on the board. Now, this infrared remote sensor, you can power it with 3.3 volt or 5 volt. Since my microprocessor here is 3.3 volts, I have to power the infrared remote control 3.3 volts so that the output, the signal level will also be at 3.3 volts. If your microcontroller board is 5 volts, the signal in on the pins are 5 volts, then you can power this with 5 volts. So now make sure you connect a non-polarized capacitor for filtering. So this is how the entire system is wired. You understand? So then this is the relay. So you see, so this is my infrared remote control. If I press a button, let's say I have media player. Let's say I'm playing some videos on my PC and I don't want to, let's say this is your computer keyboard. It is your computer keyboard. Instead of coming here and be pressing the arrow keys up, down, left, right for controlling the media or your PowerPoint presenter, so I just simply stay some distance away and then use my infrared remote control. I press in. For instance, I want to play the media. I press the button for play and signals come in here. Microcontroller takes in the signals, send them to the computer. So the software running on the computer, which I have also developed, will interpret the signals. For example, if I press play button, the software here will interpret it as play, as a space, as if I pressed space bar on it, then the media will start playing. If I press the volume up key, it will transmit as I'm pressing an arrow key up. You understand? Arrow key up, down. So you understand? So that's how I map the system, like this: arrow keys up and down. If you're playing various media, let's say you're playing some videos, pressing this arrow key up, you're going to increase the volume. Although I also have volume keys here, which I've also mapped them. Pressing this arrow key up, you're going to increase the volume. Pressing the arrow key down, you're going to decrease the volume. Then pressing this, you're going to push the play backwards. You press this and you forward the play forward. You understand? Then this menu key, I map it to enter key on the keyboard. You understand? So that was what I did here. Then this, I map it to pressing S on the keyboard will stop the media, your VLC player, from playing. Then this green one, I map it to your space bar on the keyboard. You understand? I mapped it to space bar on the keyboard, just like what you're having here. So this is what I did. Let me show you. So you can see these arrow keys on our keyboard. So I map them to this, and then this, my enter. So if I press this, the operating system is going to think I press this and it's going to react accordingly. If I press this, the operating system will think I press this, the same thing. So if you press the space bar, it's going to stop. You're going to pause or play your media. I mapped it to this green button. If I press this, it's going to play and pause. Then if you press N here, next it's going to move to the next track. This blue button here, the same thing I did. If I press it here, it's going to move to the next track. Then if I press P on the keyboard, it's going to which is mapped to this one, going to move to the previous track. So you see, that's exactly what I did. Although I also mapped some keys here, like this. If I want to turn off this light, let's say we connected an external power this into through this, and I want to control it from the remote control, like what we have here. Let's say you want to connect your lighting point, this which is what you are seeing here. So this is how you wire it. So you can see this. This is your power source. If it is AC bulb, you wire it this way. See these two terminals, one on the terminal, then the other terminal goes to the bulb. Then let's say your live terminal comes through this way, goes to your live terminal of the bulb, then the neutral from your source goes to the neutral terminal of the bulb. That's how you wire it here. And then you plug in your 12 volts adapter, as you can see here. So that on the remote control, this is the button I use. If I press this, it will turn off the lights. If I press it again to turn on, let's say you guys want to watch movie and you want the lights to be off, you pressing this is going to turn off the light. It's the same thing I did on the Android. I will show you the interface of the Android app later. So you see, so that's how they designed it. Then what did I do here? In case you are not using this, you can also construct this with any of this. If you don't have this LGT, or if you have Arduino Nano, you can also use it to do the same thing I did here. Which means that one you have to buy a Bluetooth module separately. So because of didn't do that, I just get this, so that to reduce your cost, you have buying your Arduino Nano board and then buying Bluetooth. If you add the money, the cost of it is going to be more than this. So the best is just get this. There are different versions of this, although the version I used here is a cheaper one, the smaller one, but still ESP32. You understand? So which is what I did, since this one have the inbuilt Bluetooth. So I wouldn't want to use this. If I'm using this, or you're using Arduino Nano, Arduino Uno, you have to buy a Bluetooth, because these don't have such kind of communicating devices in them. So your ESP32 have Wi-Fi and Bluetooth. So inbuilt, the Bluetooth is inbuilt. So you can see, so which makes for connecting my Android phone to it. So you see, so that's how the entire system works. So the aim of this is to be able to control media on your laptop or on your desktop computer, as if you are operating your DVD player with it. So you see, earlier when I started embedded systems, back then, it became a problem. Listen, I was so worried how I would want to like use this on my laptop. How can I do it? How can I do it? So as my programming experience grew to a point where I sat down one day and I decided, okay, I'm going to use this. Now, there are three softwares that I did. One of the software which is going to be running here, which is the firmware. I've mentioned this before. Software that's in the hardware for making the hardware functional is called firmware. Then the other one on your computer, I developed another software on the computer. Then on the Android phone again, I also developed another software. So what these two do, your Android phone and this infrared remote control communicates with this. This now communicates with your computer. So for instance, you are doing presentation, you are using the Android phone, and let's say your phone runs down or something else happens with the phone, you can as well continue with your infrared. Now of the things with infrared is that they operate on line of sight. Line of sight. It means there have to be a straight line. You have to align, point this in to the sensor. For example, now if you cover this sensor such way you can't work, you can't be able to operate it. So that should be seeing the sensor. Or if there is something that can, there is something as an angle here, even if I point this, it's going to still reflect the wave to this. So you need to go and study the theory of infrared remote controls. Go and study the theory of infrared remote control. So here we have just the white man made this for controlling our TVs, our DVDs, and other gadgets. But here, I also want to use them and convert them and hack them to make something that I can be able to at least be operating my computer, playing media on my computer connected to the projector. I can just sit back and just use this and be operating it in my computer. So that is one of the things, one of the good things of learning embedded systems. Just like as I mentioned earlier, embedded system is hardware plus software. Creating a hardware, creating a software to make something do something useful. Just like this, I'm using this on my computer instead of TV. So you see, now it's not just any remote control can be used. Now, what is not about this, it's not just about this, it's you. But what is happening here, you the programmer, whatever this microcontroller is doing, you are not doing it. You understand? Just like you have what embedded system is, just like you have what's in your brain, you transfer it to the brain of these microcontrollers or the microprocessor. So whatever this thing is doing is you. So you are the one telling this thing, okay, this is what I want you to do. This is what I want you to do. So some guys thought that you just can just buy this in the market and just connect it and just bring any remote control. No, you can't even carry it. For example, now if you bring if I bring this remote control, it can't work here because the program I've written is for this remote control. This Philips remote control, this is NEC protocol. This Philips protocol, this NEC protocol. So if I press my arrow keys here, it's not going to do anything. You understand? Although the microcontroller is any remote control you bring here, the microcontroller will detect all, but the microcontroller will only act on the buttons, the commands those buttons are giving. So all these buttons here, the commands they give you, all are entirely different from this. So you can see, so each one of these buttons, they transmit two commands. Number one of the command is the protocol of that remote control, and then the value of that particular button. So you see, so it's the value of the button which we need to use in your program. So if I'm to use this, I will have to decode this and write program for this and then add it here. So whatever, and I can use I can add any number of remote controls, but make sure they have different protocols. Like this is NEC, this is Philips. We also have Sony. We have different protocols. You understand? I can add as many remote controls as I want. So if I want to add this, I can write program for this and then add to this. So before you use any remote control, you should know how to decode remote controls with your whichever programming language you are using. Just like I mentioned earlier, here is Arduino C programming language that I used there. So what I will do next, I'm going to in my next video, I'm going to connect this so that you see how it works. You understand? We're going to connect this. I'm also going to show you the program, which although here I haven't put in the pins that I used here. So in our next video, we're going to connect this to the computer, and then we're going to test everything and see how it works. So make sure you share this video if you benefit from it, like it, and also subscribe. Thank you.